Hello students, good morning. Again welcome back to our science class, online science class of class 8th. Today we are going to start a new chapter. The name of the chapter is friction and this is chapter number 12, part 1st. In this chapter we are going to discuss about the certain topics. The first topic of this chapter is, firstly we are going to know about that what is friction. Then after we are going to know that what the direction of the force of friction. Then we are going to know about that factors affecting friction and about the types of friction. So these things that we are going to discuss in this chapter one by one. So let's start with the first topic of this chapter, that is friction. So firstly we'll know that what is friction. Now here there is one example that is given to you on the slide. That example is a ball is rolling on ground and gradually slows down and comes to rest due to the force of friction between the ball and the ground. This you have seen also. When you roll a ball on a ground, after covering some distance it comes to rest. Why it comes to rest? This question arises in your mind. That is mainly due to the friction. Means that there is some force that acts in the opposite direction of the moving ball, and that opposite motion, and that force is known as the frictional force, or we can say it friction. So how we can define it, that what is friction? The force which opposes the motion of one object over another object in contact with it is called friction. So we can say that the force which opposes the motion of one object over the another object in contact with it is called friction, or it is a kind of opposing force that opposes the motion of the moving object. Now let's take another example. When we push a box lying on the floor with a small amount of force, it does not move at all. When you apply a force on a box that is lying on the floor with a small amount of force, you have seen that it does not move at all. It means that the surface of the floor on which the box is resting exerts some force on the box which acts in a direction opposite to the force of our push. Or in other words, we can say that some force is acting on the bottom of the stationary box which opposes its motion, due to which the box does not move. This natural force between the floor and the bottom of the box which opposes motion is commonly known as frictional force. So we can define the frictional force like this. The force which always opposes the motion of one object over another object in contact with it is known as friction. It is a type of contact force. Now we are going to know about that direction of the force of friction. So let's know about that, the direction of the force of friction. So here there is a one diagram that is given to you that shows the direction of the force of friction. Look at the diagram here. That diagram shows you the direction of the object in which the object is moving, and the direction of the friction in which that frictional force is acting on that moving object. So this diagram clearly shows you that the frictional force always acts in the opposite direction of the moving object. So the force of friction always opposes the motion of one object over the another object, so that the force of friction acts in a direction opposite to the direction in which an object moves or tends to move. Now here we are going to know about this with the help of one activity. In this activity, first of all, place a brick on a floor and tie a string or strong thread around the brick and connect it to the hook of a spring balance. We are knowing that the spring balance is a device that is used to measure the frictional force. So just tie it or connect it to the hook of a spring and applying a pulling force to the brick by pulling the other end of the spring balance by the hand till the brick just begins to slide or move slowly on the floor. Note down the reading in the spring balance when the brick begins to slide. This reading of the spring balance will give us the magnitude of the, whatever the reading that you will get in that spring balance will give you the magnitude of the force of friction between the surface of the floor and the surface of the brick, which are in contact with each other. Now let us now wrap a piece of polythene around the brick. Firstly, we have not wrapped the piece of polythene around the brick, but here in second case we are going to wrap a piece of polythene around the brick and repeat the above activity. We note that the spring balance reading when the polythene is wrapped around the brick just begins to slide on the floor. We will find that the reading of the spring is smaller than the first reading of the spring and when there was no polythene around the brick, indicating that the force of friction has decreased. So the wrapping of the polythene sheets makes the surface of the brick smooth and due to which the friction with the floor decreases. Now remove the polythene sheet from the brick. Now wrap a jute cloth around the brick and repeat the above activity once again. We will note that the spring balance reading when the jute wrapped brick just begins to slide on the floor. In this case, we find that the reading of the spring balance is greater than the first reading of the spring balance when nothing was wrapped around the brick, indicating that the force of friction has increased. So wrapping a jute cloth that makes the surface of the brick more rough and due to which the friction with the floor increases. Now from above these activities we have learned that when the surface of the brick is made more smooth by wrapping the polythene sheet, the friction with the floor decreases. On the other hand, when the surface of the brick is made more rough by wrapping a jute cloth, then the friction with the floor increases. Thus, the friction depends on the nature of the two surfaces. That is, the friction depends on the smoothness and the roughness of the two surfaces. So, we can say that the friction depends upon the roughness and the smoothness nature of the two surfaces. Now, factors affecting friction. So, in this activity I have already told you the first factor. The first factor is the nature of the surface and contact or the smoothness of the surfaces. So from this activity it is clear to you that the friction depends upon the nature of the surfaces in contact. The friction is more on the rough surface and it is less on the smooth surface. Now second factor is how hard the surfaces are pressed together. The friction is less on a smooth surface. Now here with the help of the activities we are going to know about the factors that affects the force of the friction. Now there is one activity. In this activity, make a inclined plane on a smooth marble floor by keeping the wooden board in a tilt positions with the help of a brick placed behind the wooden board. Mark a horizontal line with a ball pen on the upper half of the inclined wooden board. Hold a pencil cell on line AB and marked on the inclined wooden board and release it. The pencil cell will move down rapidly with the inclined board and travel a certain distance on the marble floor before coming to rest or stopping. The moving pencil cell stops due to the friction exerted by the marble floor. We note the distance that covered by the pencil cell on the marble floor. This distance will give you the idea of the friction between the marble floor and the pencil cell. Now let us put some water on the floor and make it wet and repeat the above activity by releasing the pencil cell from the same line AB of the inclined board. And again the pencil will travel the certain distance on the wet marble floor before coming to rest. We note the distance that is travelled by the pencil on the wet floor. We will find that the pencil cell travels a larger distance on the wet marble floor, indicating that the friction on the wet marble floor is less than on the dry marble floor. So from this activity it is clear to you that if we increase the smoothness of the surface, in that case the friction will be less. And if we will increase the roughness between the two surfaces in contact, in that case the value of the friction is large. So it is clear from this activity that pencils, in first case, when it is released from the inclined plane and there is a mark that is made on that inclined plane, that is AB, when it is released from that inclined plane, it covers a certain distance on the marble floor. So we just note down that the distance that is traveled by the pencil in first case, and in second case, when you make that marble floor wet and then repeat that activity again and release that pencil from that mark that you have already made on that inclined plane, you will notice that the pencil will cover the large distance. So this activity shows you that by making the marble floor wet, it decreases its roughness and the surface becomes smooth, and in that case the pencil will cover the large distance. It means that the friction becomes less here. So we can say that the friction depends on the smoothness and the roughness of the two surfaces. So the second factor is dependence of the friction on the force with which the two surfaces are pressed together. Now just think that I have already told you that the friction is more on the rough surface and it is less on the smooth surface with the help of an activity. Now friction is more if the surface are pressed harder and friction is less if the surface are not pressed harder. So this is clear to you with the help of this activity. Now I am going to give you one example. In this, suppose that we have the two boxes of the same size, but one box is light and other box is heavy. So you have the two boxes, one and both of them are of same size, but one box is light and other box is heavy. So if we push that two boxes on the floor one by one, we will find that we have to apply only a small force to make the lighter box to move on the floor, but a larger force has to be applied to make the heavier box to move on the floor. This shows that there is a less friction between the light box and the floor, but much more friction between the heavy box and the floor. So we just know that the weight of the box is also a force which acts in downward direction. Now because of its smaller weight, the light box presses on the floor with less force, hence the friction between the light box and the floor is less. This lesser force of friction allows the lighter box to move easily by applying a smaller push. On the other hand, because of its greater weight, second box is of large weight. So because of its greater weight, the heavy box presses on the floor with a greater force, and since the surface of the heavy box and the floors are pressed together harder with a great force, and the friction between them increases and becomes much greater. This greater friction does not allow the heavy box to move on the floor by applying a small force. A much larger force of a push has to be applied to make that heavy box to move on the floor. So it is clear from this activity that if the weight of the box is light, in that case it applies a small amount of the force on the floor, and in that case the frictional force will be less. And if the weight of the box is heavy, it applies the greater force on the floor, and in that case the frictional force is large. So it is clear from this activity. Now cause of friction. Now we are going to study about the different cause of friction. So let's know about the cause of the friction one by one. Here friction is caused due to the interlocking of the irregularities between the two surfaces in contact. Suppose that when you have kept one box when you have kept, suppose that I am going to give you one example, that suppose that you have put a one box on the surface of a floor, then in that case that the box will be in a stationary state, or we can say the rest state, and it is not moving. So it means that there is a opposing force that is acting on, there is a force, there is a some force that is acting on that box that do not make it to move. So that force is commonly known as a frictional force, and that is mainly due to the interlocking between the interlocking of the irregularities between the two surfaces which are in contact with each other. So the friction is mainly caused due to the interlocking of the irregularities between the two surfaces in contact. The smooth surface have the minute irregularities, while the rough surface have the more irregularities. So the smooth surface have the minute irregularities between the two surfaces, and the rough surface have the larger irregularities between the two surfaces. So the force of friction is more if the surface are rough. Now we are going to know more about this. Every object have a rough surface. Though the surface may appear to be smooth to the naked eyes, when we see it through a microscope, it is found that the surface of all the objects have the rough edges. Some of the particles on the surface of the object are in the form of tiny hills, while others form groups. The tiny hills and groups on the surface of the object are called these tiny hills and groups are commonly known as the irregularities of the surface. When we try to move one object over another object, then the irregularities that is present on their surface gets entangled, or we can say gets interlocked with one another. And this interlocking of irregularities of the two surfaces opposes the motion of one object over the another and gives rise to the force of friction. So we can say that the friction is caused by the interlocking of the irregularities in surface of two objects which are in contact with each other. When we attempt to move one object over the another object, we have to apply a force to overcome the, suppose that if you want to move one object over the another object, so in that case you have to apply a force in order to overcome the interlocking of the irregularities, because when one object is kept over the another object, the irregularities that is present between their surface gets interlocked. So you have to apply a force to overcome these irregularities, interlocking of the irregularities in their surface. So more the roughness of a surface, larger is the number of irregularities on the surface, hence greater will be the friction. The force of friction is greater if the rough surface are involved. Now in second case, that the smooth surface have the minute irregularities between the two surfaces, so in that case the frictional force will be less. Now here we are going to know more about that. There is a device that is used to measure the frictional force, and the force that is acting on an object that opposes motion or make the object to be in stationary state. So the name of that device is spring balance. So we can say that the spring balance is a device which is used for measuring the force that is acting on an object. Spring balance mainly contains a spring which gets stressed when the force is applied to its free end having a hook. The extent by which the spring gets stressed is a measure of the force applied. Larger stretching of the spring, greater will be the magnitude of the force applied. The stretching of the spring or the magnitude of the force is indicated by a pointer which is attached to the spring, which moves on graduated scale. The reading on the scale of a spring balance that is indicated by the position of a pointer gives us the magnitude of force. So it works like this way. So we can say that the spring balance is what? It is a device which is used for measuring the force acting on an object. And how this spring balance works, I have told you that how it works. And what is the structure of the spring balance? Now, as I have already told you, and this diagram shows you that when the one object is kept over the another object, then the irregularities that is present between their surfaces get interlocked with each other, and that is responsible to cause the friction. So the friction is caused by the interlocking of the irregularities between the two surfaces which are in contact with each other. And we are knowing that not any type of surface is perfectly smooth. There are some irregularities and it appears smooth to us with our naked eyes, but when we observed it with the microscope, we will observe that there are some minute irregularities are present. So we can't say that any type of surface is perfectly smooth. So here this picture shows you that when the one object kept over the another object, then the interlocking between the irregularities that is present between the surface gets interlocked, and that mainly cause the friction. Now, types of friction. Now we are going to know about that. What are the different types of friction? The friction is of three types: static friction, sliding friction, and rolling friction. Now one by one, I'm going to tell you about the static friction, sliding friction, and rolling friction. So let's start with first one, that is about the static friction. We are going to know about that. What is static friction? Static friction is a kind of starting friction because an object just tends to start moving, or we can say that it does not actually move. So when the object just tends to start moving or it does not actually move, in that case the friction that occurs during that time is commonly known as static friction. The object remains static or rest, or we can say stationary in this case. So the maximum frictional force that is present between the two objects when one object tends to move or slip over the surface of the other object is called the static friction. So we can define it like this: there is a maximum frictional force that is present between the two objects when one object just tend to move or slip over the surface of the other object is called the static friction. So it is a kind of starting friction, because here in this case the object just tend to start moving or it does not actually move. Now this is clear to you with the help of this activity that I am going to tell you. Suppose that take a wooden block having a hook that is attached to its one side is kept on a horizontal surface on a table. A spring balance is attached to a hook. I have already told you about the spring balance and how it works. So the spring balance is attached to the hook of the wooden block, and we pull that spring to the right side with a small force of our hand. When we exert a force on that wooden block, the wooden block does not move because its motion is being opposed by the force of friction which acts in opposite direction to the left side. So we are pulling it on the right side and there is a opposing force that acts in opposite direction to the left side that opposes motion. So as we increase the pulling force that is applied to that wooden block through a spring balance, the friction also goes on increasing, but ultimately when the applied force becomes little more than the maximum frictional force, the wooden block just tend to, so we keep on increasing the pulling force on that wooden block so that the friction also goes on increasing, but ultimately when we apply the force with a little more than maximum frictional force, the wooden block just tends to move or slip on the surface of the table. This means that the frictional force acting between the wooden block and the table top has the maximum value beyond which it cannot increase. The force we are exerting in making the wooden block just tend to move or slip is equal but opposite to the force of friction. So here the friction that occurs in this case is a static friction. When that wooden block is in stationary state or just tends to move or slip, or actually it is not moving, then there is a opposing force that acts on that wooden block in opposite direction which does not make it to move, and that frictional force is commonly called a static frictional force or static friction. So the static friction comes into play when we try to move a stationary object which is at rest. Here in this case, the static friction the object is actually not moving or sliding over the here the that in this activity that I have told you that the wooden block is in a stationary state means that it is not moving. So it is not actually moving or sliding over the other object, or it tends to move or slide. Now we are going to know about the sliding friction. So as I have told you about that what is static friction, now the second type of friction is the sliding friction. The frictional force present when one object moves slowly or slides over the surface of another object. When one object slides over the surface of another object, there is a frictional force acting on the object in opposite direction. That opposite motion is commonly known as sliding friction. So the sliding friction comes into play when the object is sliding, moving slowly continuously over the object. Since the sliding friction is small than the static friction and it is easier to keep an object moving which is already in motion. So we can say that the sliding friction is smaller than the static friction because it is easier to keep an object which is already in motion than to move the same object at the rest position. So we can say that the sliding friction is smaller or less than the static friction. When an object has already started moving, or we can say or sliding, then the irregularities on its surface do not get enough time to lock into the irregularities on the surface of the other object completely. Since the interlocking of the surface is less, here the interlocking of the surface is less when an object has already started moving. So therefore the sliding friction is smaller than the static friction. If the question may be asked that why the sliding friction is smaller than the static friction, then you will give this answer that when the object which has already started moving or sliding, the irregularities on its surface do not get enough time to lock into the irregularities on the surface of the other object completely. So here there is the locking of the interregularities between the surface is very less. Since the interlocking of the surfaces is less when an object has already started moving, and therefore we can say that the sliding friction is less or smaller than the static friction. But what happens in case of static friction? In case of static friction, the object is at rest position or stationary position, so the interlocking between the two surfaces which are in contact with each other is much larger. So we can say that static friction is larger than the sliding friction, or sliding friction is less than the static friction. Now we are going to know about that what is rolling friction. So when an object like wheel that rolls over the surface of another object, the resistance to its motion is commonly known as rolling friction. And it is always easier to us to roll than to slide an object over the another object. So the rolling friction is much less than the sliding friction. Rolling friction. Now here we can understand it with the help of this activity. Suppose that let's keep a thick book on a table and now push that book with your hands. We will find that it is not easier to push that thick box that is lying on the table and make it to move or slide. So we have to apply a fairly large amount of force to make that book to move or slide on the table. This is because when the book is lying directly on the surface of the table moves, then the sliding frictions come into play. The sliding friction between the surface of the table and the bottom of the thick book makes the box comparatively difficult to move. Now take 3 round pencils. Round pencils are cylindrical in shapes and act as a roller. Now place these round pencils parallel to one another on the tabletop, and let's place that same thick book over the round pencils. Now push that box with your hand. When we push the box, here in this case, the round pencils kept below start rolling or turning like wheels and make the book to move forward easily. We have to apply a very small amount of force to make that book to move when it is placed on rollers, or we can say on the round pencils. So it is much easier to move the book that is placed on rollers than to slide it directly over the surface of the table. It is much easier to move an object that is kept on rollers than to slide it, because the rolling friction is much less than the sliding friction. Heavy machines can be easily moved from one place to another place by placing the round logs of wood under them, then pushing it with a force of hands. The round logs of wood act as a roller, a kind of wheels, and make it much easier to move the heavy machine kept on them. So this is clear from this example that the rolling friction is less than the static friction and the sliding friction, because it is much easier to roll the object than to slide it. And it is clear from this example and from the activity that I have told you. So here in this activity, what we have observed that when the book is kept on a table, the surface of the book is in direct contact with the surface of the table, and if you want to move that books by pushing that book with your hand, in this case it is difficult to you that to push that box on that table. But when you kept the cylindrical pencils below that heavy book, and then after again push that book to move it, then here what happens that you can easily move that book. So this is clear to you that in the first case sliding friction X, and in the second case rolling friction S, and this rolling friction reduces the amount of friction. So the rolling friction is much less than the sliding friction and the static friction. So this is about the rolling friction, about the static friction, and about the sliding friction. So I have told you about all the three types of friction. So here there is one diagram that is given to you that shows you the rolling friction, sliding friction, and the static friction. The first diagram shows you the static friction, the second one shows you the sliding friction, and third diagram shows you the rolling friction. So this is about the some topics that I have told you today. Still some topics are remaining, that we will come back with the other topics very soon. So try to revise all the topics and try to do the exercises related to these topics that I have told you today. So students, do your work on time and do your studies well. Thank you.